So, announcements are fairly straightforward. Chapter 17 homework is due on the 25th. The chapter 17 quiz will be on the 25th. We're going to be finishing chapter 27 today. The quiz and the homework are due so late because next week we will not be meeting Thursday or Friday because of Easter. So, continuing on with other moons in the solar system. We talked about the moons of Jupiter. Now we'll move on to Saturn. Saturn is the planet with the most known moons. It has 146 known moons currently. Your textbook is out of date. It says 82. We keep finding more. Also, there is an orbiter around Saturn, or there's been an orbiter around Saturn, so that helps identify more moons. The largest of these is Titan. Titan is interesting because it's the only moon in the solar system with a thick atmosphere. So Titan has actually a pretty thick atmosphere that's mostly nitrogen, and the combination of the relatively thick atmosphere and the low gravity means, amusingly, on Titan, if you strap wings to your arms, you could fly. And it's not like the pressures aren't crazy or anything. They're pretty similar to Earth's atmospheric pressures. You need breathing apparatus because there's no oxygen in that atmosphere and it's cold. But yes, it's the only moon in the solar system that has known to have a dense atmosphere. The atmosphere is rich in nitrogen. It's about 90% nitrogen with argon and methane in addition. Oh, oops. And Titan's surface is also interesting because it's the only body other than Earth in the solar system that has lakes and rivers. They aren't of water, but they are of liquid methane. It has lakes and like streams and like a cycle of liquid methane. So here is a video showing an overview of the surface of Titan. So this flies over the hydrocarbon seas and lakes. That had to be viewed with radar because Titan has a thick layer of clouds covering it. But we have sent a probe down to the surface. One of the other interesting things is Enceladus. Enceladus is a smaller sized moon. It's the small size of medium moons, but it has liquid water underneath it. And we know this because we found geysers spewing out water from Enceladus, the fountains of ice particles and water vapor from the surface of Enceladus that indicate that there's ongoing geological activity. So one of the very interesting things was found was this water on Enceladus. Oh, sorry?
I wanted to ask you, so anything along using like large rock that has water inside.
If they have liquid water, it's a possibility. It needs to be liquid because lots of stuff out there has water, but it's mostly frozen. So places that have liquid water that we think might have life in the solar system are places like Europa, which has that ocean, other places that have oceans. Enceladus is a maybe. It's small though, so but yeah, anywhere with liquid water is a maybe. I mean, we never found anything, but I mean, like, and that's why, for example, one of the most recently launched major probes, the Europa Clipper, its goal is to study Europa in more detail, so we'd have a better idea of what's going on there. And that part of that is because it's likely to have as far as we can tell, it has an ocean and active and likely to have active like geology, so it would have things like geothermal vents. And as far as we know, that's where life started on Earth. So yeah.
How big is Europa compared to here?
So Europa is a bit smaller than the moon. So but the entire surface is covered with an ocean. So it actually has more water than it. Because it's like rock, ocean, ice. But yeah, but if you want to scale, it's on the same sort of scale as the moon. It's a bit smaller than the moon. Let's see here. Europa is about 65% of the mass of the moon, and its diameter is just a little bit smaller. You know, the moon's 3,500 kilometers or so, and Europa is 3,100. So it's just a bit smaller than the moon. Enceladus, on the other hand, is tiny.
Yeah.
This is only a few hundred miles across. But it has liquid water on it, so who knows?
Recently, Cassini has found that a tiny moon that orbits around Saturn has jets and plumes of water coming out of it. These particles go out and they form the E-ring. And in flying through the E-ring, one of the instruments on Cassini, the Cosmic Dust Analyzer, can take those particles and get a composition. And as part of that, they see salt.
This is salt, and this is what we found in the ice particles we detected in Saturn's E-ring. And what we think is that the salt comes from an ocean below the surface of the moon Enceladus.
The sodium is a tracer for a subsurface ocean. That's the material of the ice particles, a kind of water, like on Earth.
And that salty ocean tells us something about what might be going on inside of Enceladus to create the jets and plumes that you need. Water, liquid water, in contact with the rocky core to get out the sodium. You could sort of think of maybe the plumes of maybe sort of the breath of Enceladus, coming out and telling us something about its interior.
So what we can say is we have a reservoir of liquid water, and liquid water is one of the preconditions for forming life.
I was surprised and also very excited to find out that, we're getting closer and closer to the conclusion that you have liquid water, possibly a liquid ocean, on a moon that's so tiny, and in a place where we didn't expect to find conditions where you might find life. This tiny moon, just 300 miles across, that might have liquid water and the conditions, the precursors for life. The focus, as Cassini continues in its Equinox mission and continues on into the future, will be to have more close flybys of Enceladus, to fly through that plume, fly close to this tiny moon to learn more about the processes going on inside.
So, it also turns out that moons and rings are interconnected. Without moons, rings would not exist. You have seen in that previous video, Enceladus generates the particles that form one of Saturn's rings. Moons both provide the material to feed into the rings, because rings aren't really stable on their own. They just fall apart over time. So they need to be fed with new material. They lose material steadily. Because they're chaotic systems, stuff bumps into each other. And on their own, if there weren't something to help keep them combined, they just disperse. So moons keep rings combined in two ways. There are shepherd satellites, which are small moons in between the rings that help gravitationally pull the rings together. They keep the ring particles in place. Otherwise, also, rings would dissipate over astronomical timescales if they aren't resupplied. And new particles come from impacts on moons, things like Enceladus spewing geysers out, feeding into the rings, things like that. But shepherd moons keep the rings organized and stable. So here you can see these are a pair of shepherd satellites on Saturn's F ring. And you can see how that gravitational force is tightening the ring up, pulling it together. The other factor that affects ring stability is orbital resonance. So the larger moons, their orbits make certain orbits at the distances where rings are more stable or less stable, and that helps keeps the rings confined as well. So the larger moons also create the larger scale structure of the ring. So it turns out, like the gaps and dense portions of rings, you can actually, like for Saturn, you can tie the gap to a certain resonance with, I think, Titan. But yeah, they correspond. Now this is Uranus. These are classified all as medium moons because they're smaller, but these are the larger moons of Uranus. Uranus has Miranda, Ariel, Umbriel, Titania, and Oberon. And Uranus is kind of unique in that its moons are not named after Greek gods or Roman gods. They are named after characters from English literature. But these are all characters from Midsummer Night's Dream. Fairies from Midsummer Night's Dream. Uranus has 28 known moons. Miranda's interesting because it's a mess. It's it looks like it shattered and reformed. And these are some of the other ones. So Miranda has strange, bizarre geologic forms. It hasn't really, it's kind of a mess. Neptune has 16 known moons, of which Triton is the largest. Again, the textbook's out of date. A couple more moons have been found. Part of the reason, we haven't found too much more at Uranus and Neptune is because they haven't been visited since the Voyager probes. So, but what? It's hard. It's expensive and hard. Basically, like it takes a long time. You need a good solid plan. And I think they're getting more interesting stuff out of, and it's just harder to do things like actually put something in orbit around them. It's just they're so far away that it becomes more difficult. We didn't even know all the moons around the things we have active stuff orbiting them. So, we don't have like telescopes. I mean, you can, but they're hard to see. They're little. They're little and very far away.
Wait, that's crazy.
I mean, think about Neptune. Neptune is like, it's like 100, no, it's like 30 astronomical units out there. So it's like 30 times as far away from the sun as Earth.
Yeah, like we can see like light years away. But...
Yes, but the things we see that are light years away are generating light. They aren't small things reflecting light from the sun. So most of the stuff we see that's really far away is a star.
Yeah. I didn't. Okay.
I mean, yes, we can sometimes, but yeah, kind of the issue is just, and we found all the big ones.
Yeah.
It's that we keep finding smaller ones. Yeah, like they're smaller than lots of asteroids. These are not huge moons. And the extra moons they're finding fall into like the small moon category, smaller than any of the moons we've talked about. Now, but Triton is interesting because Triton orbits Neptune backwards, basically. It's going the opposite direction than Neptune is rotating, in the opposite direction than everything else in the solar system is rotating. It's retrograde. And it's the only large moon that has a retrograde.
Is that because of that?
Probably what happened with Triton is that Triton didn't form. So most large moons formed with the planet they're with. It's believed that Triton is an exception of that. It was captured. So it was an object that was flying around on its own and it got caught by Neptune. But there's still confusion about that because it would have had to slow down enough to end up in orbit around Neptune. And it's hard to conceive of a way for it to slow down in such a way that it wouldn't be destroyed. Yeah, because basically it would have to run into something. But if it runs into something enough to slow it down, that probably would be enough to destroy it. So there's still a lot of questions about Triton. But Triton is, it's very cold. And kind of unique looking. So this is a short video about why Neptune's moon Triton orbits backwards and why it's strange.
(1989). After a 12-year journey, NASA's Voyager 2 mission reaches the outer solar system and the gas giant Neptune.
First seeing the images of Neptune was really exciting because we went there with no idea what we were going to find, and suddenly here are these high-resolution images.
It's a triumph for Voyager 2. But when NASA examines Triton, the largest of Neptune's 13 moons, they spot something disturbing. The moon is going the wrong way around the planet.
When you look at the Earth-Moon system, the moon's going around the Earth just like this, kind of close to the equator of the Earth. When we look at Triton, what we see is the moon's going around in the other direction. It's the only large moon of any of the planets that does this.
Triton's behavior seems completely unnatural. It contradicts everything we think we know about how planets and moons form.
Most moons get created as the planet itself gets created. So you have this swirling ball of gas and materials that are collapsing down into the central planet, and then some debris left over collapses down into the satellite. So you expect all the objects to go in the same direction around the planet. That's very understandable. What's not understandable is how do you get a moon, especially a large one, to go in the opposite direction.
The resemblance to the planet-destroying artificial moons of the Star Wars movies is striking.
As they're approaching the Death Star, Obi-Wan peers through the windshield and says, "That's no moon."
If you want to park in the solar system, keep an eye on Earth and all the interesting things going on there, Neptune's the perfect place to park your artificial planet.
Triton's surface seems to support the theory. It appears to have areas that are smooth as metal, reflecting 70% of the sun's rays.
Triton's a very confusing world. It's the orbit and it's the type of moon it is. Yeah, Triton is very confusing.
Even for the most skeptical scientist, all the evidence suggests that Triton is no ordinary moon.
It's extremely unlikely that Triton formed orbiting around Neptune. It doesn't make any sense for it to have formed locally.
There is one obvious problem with the Death Star theory.
If I'm flying an artificial planet through space and I decide that I want to park it on Neptune, I'm going to be sure to go the right way around the planet if I'm trying to hide.
Triton is not a Death Star. It's not made out of materials we'd expect it to be made out of if somebody was building a thing. It's made out of natural materials that we expect.
But if Triton is not artificial, why is its surface smooth?
On Triton, we saw eruptions of material into its thin atmosphere. Watery eruptions can freeze and make a smooth surface, at least filling in the impact craters.
People call it cryovolcanism, an ice-based, cold, volcanic process.
That still leaves the mystery of Triton's weird orbit. But astronomer Dr. Craig Agnor has a theory.
Because Triton is going in the opposite orbital direction of all of its neighbors, the general idea for its origin is that it made a close approach to Neptune, and it somehow became a bound companion.
Triton came from somewhere else, flying through space until it hit something near Neptune and was captured by the planet's gravity. But even this extraordinary idea only partially solves the mystery.
If the object that Triton collided with was large enough to slow it down and enable its capture, it was also likely large enough to destroy it.
To date, no one has explained how or why Triton survived its hypothetical collision.
That's Triton. It's one of the coldest places in the solar system. And part of the problem is just any sort of visit to the outer planets takes, it takes like a decade to get out there. And it's just difficult. So, we sent stuff out to Jupiter and Saturn, but that's relatively easy because they're a lot closer and you can gravity boost off Jupiter to various places. But not just full-size planets, major planets have moons. Like Pluto, the dwarf planet Pluto, has 5 moons. Pluto has 5 known moons. They're Charon, Styx, Nix, Kerberos, and Hydra, all named after Greek mythological figures associated with the underworld. The largest Charon was discovered in 1978. Charon is actually about half the diameter of Pluto. It's really big compared to Pluto. Making it the largest satellite in relation to its parent planet. And the same side of Charon and Pluto always face each other. They're tidally locked to each other. And so they always orbit together. And then there are 4 more small moons orbiting Pluto. And other dwarf planets have moons. I think Haumea is known to have 2 moons. Eris has 1 known moon. I don't know if Makemake has a moon.
You may have noticed that we now have only 8 planets in our solar system. Most of us grew up with 9. Pluto was the 9th, but it's no longer a planet. I'll explain why not, and also, if Pluto is no longer a planet, just what is it? Pluto was discovered back in 1930 and added to the list of planets. Its orbit is a strange one, taking it for a time closer to the Sun than Neptune. But more of its time is spent beyond Neptune, all by itself. At least we thought it was by itself. In the early 1990s, 2 smaller objects were found in orbits near Pluto's, in what is now called the Kuiper Belt. These discoveries were followed by more objects in the Kuiper Belt, all smaller in dimensions and less massive than Pluto. But even then, some astronomers questioned if Pluto should be considered just another Kuiper Belt object instead of a planet. And this wasn't the first time something like this had happened. In 1801, a new object was discovered orbiting between Mars and Jupiter. It was given the name Ceres. During the early 1800s, Ceres, along with its neighbors Pallas, Juno, and Vesta, were considered planets. But that changed with the discovery after 1845 of many more of what are now called asteroids, also orbiting between Mars and Jupiter. After that, Ceres and the rest were reclassified from planets to asteroids, in what is now called the asteroid belt. So it was natural that many would question whether Pluto should still be called a planet, given that many more objects were found around its orbit. Pluto's status as a planet was then put under even more pressure in January 2005 when Eris was discovered in the Kuiper Belt. Eris is practically the same diameter as Pluto, but its mass is around 25% more due to its higher density. The discovery of this more massive object alongside Pluto meant that either Eris should be added to the list of planets, or Pluto should be reclassified to something else. In 2006, the International Astronomical Union, the IAU, convened to decide just what the definition of a planet should be. The final decision was that a planet should meet 3 criteria. 1. The planet is in orbit around the Sun. Check. Pluto orbits the Sun. 2. The planet has sufficient mass for its own gravity to pull it into a nearly round shape. Check. Pluto's gravity has made it nearly round. And 3. The planet has cleared the neighborhood around its orbit. This is done either through collisions or redirecting objects away. And this is where Pluto fails. Pluto accounts for only a small fraction of the mass around its orbit. To put this into perspective, there are thousands of relatively small asteroids, called near-Earth objects, around Earth's orbit. But the Earth's mass is 1.7 million times the rest of the mass in its orbit. On the other hand, you'd need around 14 Plutos to equal the mass of everything else in its orbit. So if Pluto isn't a planet anymore, what is it? At the same meeting of the IAU, a new classification was formalized, called a dwarf planet. What's a dwarf planet? A dwarf planet is one that meets the same first 2 criteria for a planet, but has not cleared the neighborhood around its orbit, just as Pluto hasn't. Plus a 4th criteria. A dwarf planet is not a satellite, like our moon is a satellite of the Earth. Check. Pluto isn't a satellite of any other object, other than the Sun, that is. So Pluto is a dwarf planet, and so are Ceres and Eris. As of now, there are only a handful of dwarf planets, but it's suspected that there may be up to 200 in the Kuiper Belt, and maybe even more than 10,000 when objects outside the belt are considered. This video was made as a collaboration with.
So this is Charon. This is an image from New Horizons. And this is from, so New Horizons was a probe that was sent out to fly by Pluto. And just to get an idea of the scale of this, it took a decade to get there. Essentially, I think it took almost 10 years. It was like launched in 2006, got there in 2015. And so this is Charon orbiting Pluto. You can see that they're actually orbiting a point in between them because Charon is so massive compared to Pluto. And this is an image of Charon from New Horizons. And unfortunately, there was no way for New Horizons to slow down, so he just did a flyby. So this is an animation of Charon and Pluto orbiting each other. And then there are several other moons orbiting out further. So this is Pluto and Charon, and then these are the smaller moons. And they have none of them are particularly round, and so they get kicked by Charon, and they have this chaotic motion. But other dwarf, as I mentioned, other dwarf planets also have moons. Some of the ones that aren't official also have moons. I think Gongong might have a moon. So other dwarf planets. So Ceres has no known moons. There are asteroids with moons, but the one that I'm thinking, the one that pops through my head is not, Ceres doesn't have any moons. It's the only dwarf planet in the asteroid belt. But there are asteroids that have moons orbiting them. But they aren't big enough to go round. Eris has one known moon, Dysnomia, of which little is known. Haumea has two known moons, Hyakka, and Namaka. I'm probably butchering those names. And they show the signature of water ice. Makemake has a single discovered moon, and other potential dwarf planets are known to have moons as well. So Gongong has one known moon, Jiangao. I probably also screwed that up. And this was discovered because of how it slowed down the rotation of Gongong. So we don't think we've never actually imaged Jiangao, but we've seen how it affected Gongong. Guar has one known moon, Wewat, and Orcus has one known moon, Bat. There's probably some others out there because we keep finding more dwarf planets. Part of the issue is that it's hard to get enough detail about these Kuiper belt objects just to be certain that they fit the qualifications. They most likely do, but yeah. There are other small solar system bodies other than, moons. There are things like asteroids, meteors and meteorites, comets, and interplanetary dust. The main difference between asteroids and comets is what they're made of. Asteroids are rocky, comets are icy. Meteoroids, meteors, and meteorites are the same thing depending on where they're located. And meteoroids are little things. And then there's interplanetary dust, which is dust. So asteroids, there are over 20,000 named or numbered objects that orbit the sun. Most of them are in a belt between Mars and Jupiter. There are asteroids outside of the asteroid belt. There's, in fact, at least one known asteroid that's entirely within the orbit of Venus. There are asteroids that intersect Earth's orbit, things like that. So there are millions of asteroids. We've just only labeled 20,000 of them. And about 100,000 of them are bright enough to be photographed by Earth-based telescopes. And these are sometimes referred to as minor planets. So you can qualify planets as major planets, dwarf planets, and minor planets. So anything that orbits the sun can be said to be a planet And then there are the major planets, which the 8 major planets. Then there are the dwarf planets, and then there are the minor planets. So asteroids are minor planets. Most of them are in this belt between Mars and Jupiter. And the reason they're there is because of Jupiter's gravity. So Jupiter's gravity makes, and there's in fact patterns in the asteroid belt that correspond to resonances with the orbit of Jupiter. So the reason, and basically Jupiter prevented anything from forming into a planet in this range by knocking things out of the way or pulling on things and disrupting the orbit. And this just settled down into sort of a ring in the few stable orbits. In the stable, this is sort of an area of stable orbits, and that's where these asteroids are with respect to Jupiter. Sometimes the asteroid belt is attributed to the breakup of a former planet, but as far as we can tell, that is not the case. It makes a great story. People use it in fiction all the time. But to the best of our understanding, the asteroid belt is made up of stuff that never formed into a planet. Never, it's just primordial. It formed into big chunks of rocks, but never combined any further. And estimates of the total mass of the asteroids is much less than the mass of an ordinary planet.
So it's something that somehow follows the things, even though I know that's beneficial to the student investor output. So all of them actually can be done differently.
So if something happens so that they could all combine, like magic spaces. The point would be there's not enough stuff there to be. Oh, okay. Yeah, there's a lot less stuff there than you would expect. So a much more plausible explanation for what's going on here is that this is debris that never formed into a planet. It's leftovers from the formation of the solar system. And it's thought that it's the reason this stuff never formed into a planet is the gravitational force of Jupiter stirring this up, causing a lot of it to get lost, and keeping it from ever condensing into a planet. And so, but that makes asteroids really useful because they're remnants from the formation of the solar system. They never went through the planet forming process. So they give us information about the starting material of the solar system. So they're useful for studying there. Now, when we look at small objects like meteorites, meteors, and meteorites, those are all basically the same thing, little space rocks. A meteoroid is one of those when it's in space. So it's interplanetary metallic or stony objects that range in size from sub-millimeter to hundreds of meters. And above that, it's likely to be classified as a meteor is a meteoroid when it is falling through Earth's atmosphere. And is on fire, well, is glowing because it is being heated up by slamming into Earth's atmosphere. And so, you know, it's the thing that forms that streak across the sky. A meteor, and then a meteorite is if a piece of that meteor makes it to the ground and you can pick it up as a rock, it is now an ite, like many other rocks. So it is a meteorite. So any meteor that survives the flight through Earth's atmosphere and actually strikes the Earth is a meteorite. And in general, for meteorites, they talk about all the pieces of a single space object that broke up as a single meteorite. That's just like a convention. But a lot of them just burn up in the atmosphere or explode. And, yeah, they never make it to the ground. Name? So here is a short video about the difference between a meteoroid, a meteor, and a meteorite.
In 1969, a celestial light show burst through the sky over Chihuahua, Mexico. These lights in the sky are called meteors. Or is it meteorites? Maybe meteoroids? Are those all different things? And if they are, what is the difference? Actually, they are all different, but they're pretty closely related. The streaks of light are in fact meteors. But the small rocky bodies that cause the lights, those are meteoroids. And when a piece of a meteoroid survives the trip and hits the ground, that object is called a meteorite. So let's talk about our Mexican light show. It actually started out as a single object about the size of a car flying through space. That object was a meteoroid, a body orbiting the sun that's smaller than an asteroid or comet. In February 1969, that meteoroid hit Earth's atmosphere and it hit it fast. Meteoroids fall at a minimum speed of 25,000 miles per hour. At that speed, the friction from the air began to heat up the object. In fact, it made it so hot that it began to burn brightly across the sky as a meteor. This particular meteoroid didn't just burn, it exploded into pieces. Now, most meteoroids burn up entirely as meteors, and some of these pieces did just that. But a few made their way through the atmosphere to hit the ground. Those remnants are known today as the Allende meteorite. Yeah, even though there are lots of stones, they're all considered part of the same meteorite. All in all, about 2 tons of this meteorite was recovered. Study of the Allende meteorite reveals that it is one of the oldest objects in the solar system, older than Earth itself. So where do meteoroids like this come from? Well, almost all of them are actually fragments of asteroids, the larger rocky bodies that orbit the Sun in a big belt between Mars and Jupiter. A few, though, are actually moon rocks, and some even come from Mars. So if you ever see one of these interplanetary travelers lighting up the night sky, now you'll know that you're seeing a meteor caused by a burning meteoroid. And if you're very lucky, you might even find a meteorite when it hits the ground.
So, so here, for example, this is the Barringer meteor crater or meteor. It's usually called Barringer meteor crater in Arizona. This is caused by a meteorite impact that's estimated to have been about 50,000 years ago when a large meteorite struck near Winslow, Arizona. This is the best preserved meteor crater on Earth, I think. Oh no, this one was bigger. The one that's always been carded, guys, they give me a damage. This was, oh, I think of, no, this was quite a bit bigger. The meteor size of a car was the one in the 60s in Allende that didn't cause a significant crater at all. So So it was caused by a nickel iron meteorite about 50 meters across. So that is not a small object. So this was caused by basically a lump of like a metallic meteorite that was about 50 meters across. And it was devastating. It killed stuff. There's evidence that this killed animals in a large range around it from the impact. And big impacts did even more dramatic things. So, you know, if you want a dramatic thing caused by an impact, there's evidence of a crater in the Yucatan Peninsula. It's called the sub-crater. That's the crater, the massive crater that is a remnant of the impact that caused the mass extinction that killed the dinosaurs. Which threw up so much material that it basically massively cooled the earth and cut off sunlight and caused death all over the place because it killed all the plants. So, but I mean, it also caused massive tsunamis and stuff. But that's how it caused a worldwide extinction event, was that it threw up so much material that it darkened the earth. But if you want to see meteors, just meteors in the sky, there are regular meteor showers, because there are basically streams of dust left behind by comets that the Earth passes through every year. And so these cause these annual meteor showers. So comets are relatively small objects that are composed of dust and ice and tend to revolve around the sun in highly elliptical orbits. So basically, stuff in the outer solar system tends to be made of ice. The comets we see dramatically are the ones that get close enough to the sun to heat up and create tails and be pretty. But those are the ones with these highly elliptical orbits. What is an asteroid and what is a comet is a little fuzzy in terminology, but comets that you see are basically, they're dirty snowballs.
Comets are created in the deepest reaches of the solar system. They travel in giant, elongated orbits far away unless some force knocks them out of their orbit towards the sun. When a comet approaches the sun, its ices and gases called volatiles vaporize to produce the tail in a process called sublimation. Although a comet is mostly ice and dirt, its surface is a shell of carbon that forms as the volatiles below the surface collect on it during the sublimation process.
It's a bit like a baked Alaska, where you take a brick of ice cream and you cover it with meringue, throw it in the oven, and the outside layer protects the inside layer from the warming influence of the sun, so it's a very complex structure.
Asteroids are other rocky bodies that also orbit the sun, but have few, if any, volatiles. They orbit either in a band of asteroidal debris called the asteroid belt, or in another, more distant band of debris called the Kuiper belt.
If you see an object and it happens to have a tail, maybe from sublimating gases or something, then they call it a comet. An asteroid is something without a tail. And that's the only distinction that observers would use.
Originally, it seemed to everyone to be clear. Asteroids were these lumpy rocks, mostly between Mars and Jupiter, but sometimes you find them elsewhere. And comets were these things that came from further out, and when they got near the sun, they'd warm up and volatiles would start to give off gases and they'd have a tail. So comets had tails and asteroids didn't.
Blurring the line between comets and asteroids even further, and contrary to popular belief, the phenomenon on Earth known as a meteor shower is primarily attributed to comets and not asteroids. A meteor is the visual display of light in the sky as a bit of dust and dirt burns up upon entering our atmosphere.
There's the dust material that comes off from a comet that makes the tail that we see in the sky for a bright comet, if that material intersects the Earth's orbit, particularly at night, then we would see meteors coming from those bodies as they hit the atmosphere and were vaporized at the top of the atmosphere.
Right now, there are about 30 to 40,000 tons of asteroid and comet material that land on the Earth every year.
That's a lot of dust burning up in the sky and settling to Earth. But it's not just comet dust that can hit the Earth. Whole comets can. Geologic evidence suggests large bodies, possibly comets, have already plowed into our planet, destroying many of Earth's creatures.
So that's comets. And a comet that comes near the sun has 4 parts. And when it's far from the sun, it's just a ball of ice. It's not doing anything complicated. But near the sun, when you see it with the tail, you'll have a nucleus. This is the core. That's typically a few kilometers in diameter, and it's got rocky or metallic material in it. Got ice there too. There is the coma, or the head, that surrounds the nucleus. This is a several hundred kilometer diameter cloud of material that's being cooked off the surface of the comet. And it's formed from the nucleus as it approaches within 5 astronomical units of the sun. So basically within the orbit of Jupiter. The tail is this long stream of stuff that's basically being blown off the comet by the light from the sun and the particles emitted by the sun, the solar wind. So the tail doesn't actually trail behind a comet. It points away from the sun. So it's a tail that's composed of ionized molecules. There's kind of 2 tails. There's a gas tail and a dust tail. So there's one that's made of like ionized gas and one that's made of dust. And they move away from the sun at different speeds. And so you can actually see the tail split, where one will curve more than the other because it's moving slower, so it's affected more by the comet's orbit, while the other one is moving faster away. And they can be millions of kilometers in length. And then surrounding the coma, there's actually a cloud of hydrogen from things like water molecules being broken up and splitting into atomic hydrogen caused by the dissociation of water molecules from the nucleus, the core. So the water molecules, there's like a cloud in the coma, and then they get broken apart by like ultraviolet radiation from the sun, and you get just hydrogen floating around. So here, there's 2 tails. There's the dust tail and the ion tail. Here, they're sort of on top of each other. But you can see sometimes the dust tail curves more than the ion tail because it's moving slow. And this is going to be, if the tails are going this way, that means the sun is over here. And in fact, the tails from a comet never actually trail directly behind it. So comet's probably moving this way. In the center is nucleus, and around that is the coma. So there's that's the head you see with the tail trailing behind it. And then around that is a hydrogen. So when they animate or draw a comet where they have it move across the screen and the tail travels behind, that's not actually correct. So here, the comet's tail is always pointing away from the sun and doesn't indicate the comet's direction of motion. So here, this is going, the comet is going this way. And as you can see here, the tail is never actually pointing back along the path, pointing away from the sun. So when the tail is most dramatic and most obvious, it's about right angles. And then towards the end, it's actually the tail is pointing in the direction of motion. So And the comet only, warms up and has tail and stuff when it's close to the sun. So for the short period of time that it's actually close to the sun, it has these structures, and then it travels out further, slows down, and spends most of its time far away from the sun, because it's a highly elliptical orbit usually. And that's why things like Halley's Comet comes every 77 years, for example. These orbits are long. So that's the end of chapter 17. Natural satellites are referred to as moons. Our moon is the largest in size of any moon orbiting the terrestrial planets. We only see one side of the moon, since its period of rotation on its axis and its period of revolution around the Earth occur at the same rate. A decent number of moons are like that, where they always have one side facing the planet they're orbiting. The gravity of the moon is only a sixth of that of Earth. Radioactive dating has shown that the moon's age is slightly less than that of Earth's. It's younger than Earth. Currently, the moon does not possess a significant magnetic field. Bowl-shaped depressions on the moon's surface are referred to as craters. The light-colored surfaces of the moon are referred to as the highlands. The dark-colored surfaces are referred to as plains or maria. And these dark areas are theorized to be the result of ancient volcanic activity on the moon. The streaks reaching outward from some moon craters are called rays. Long trenches on the moon are called moons, I think. The moon's orbit is tilted about 5 degrees with respect to the Earth's orbital plane. It takes the moon about 1 month to revolve around the Earth. The phase of the moon when the moon can't be seen is called the new moon. The phase of the moon when the full disk of the moon can be observed is called the full moon. If the moon is getting larger, we say it is waxing. If the moon is getting smaller, we say it is waning. If less than half the moon is visible, we say it is a crescent moon. If more than half the moon is visible, we say it is a gibbous moon. When the moon is between the sun and the Earth, a solar eclipse can occur. When the Earth is between the sun and the moon, a lunar eclipse can occur. The darkest shadow region during an eclipse is called the umbra. The somewhat dark region during an eclipse is called the penumbra. Tides are greatest on the Earth when the sun and the moon are in line with the Earth. And 2 high tides and 2 low tides occur each day on Earth. Spring tides occur when the Earth, moon, and sun are in line, because the tides spring up. And then neap tides occur when the moon is at first quarter and last quarter. Those are low tides, they're less dramatic tides. The 2 terrestrial planets that have no moons are Mercury and Venus. The Jovian planet with the most moons is Saturn. Io is the moon of Jupiter that has active volcanoes. The planet with the largest moon in the solar system is Jupiter. That moon is called Ganymede. And in fact, Ganymede is bigger than Mercury. The moon Titan has that's unique for a moon is a thick atmosphere and liquid on its surface. The planet with the moon that revolves in a retrograde orbit is Neptune. The name of this moon is Triton. So Titan and Triton are different moons. Try not to confuse them. Titan is orbiting Saturn. Kronos, the Greek version of Saturn, was a Titan, who were the predecessors of the gods. While Triton is the child of Neptune. Triton is sea-based. Titan is a Titan. The name of this moon is Triton. Pluto is classified as a dwarf planet. The collection of small bodies that orbit between Mars and Jupiter are called the asteroid belt. They're asteroids. A meteoroid that reaches Earth's atmosphere and glows brightly as it burns up is called a meteor. A meteoroid that reaches Earth's surface is called a meteorite. The "ite" bit means rock. Like hematite. You'll see it for lots of mineral names, like hematite, calcite. Comets usually have a very elliptically shaped orbit. The rocky portion of a comet is called the nucleus. The glowing part of the comet that forms as it approaches the sun is called the coma. Name? The rear portion of the comet that's composed of ionized material and dust is called the tail. The portion surrounding the comet is thought to be a cloud of hydrogen gas, and a tail of the comet is pointed away from the sun as it approaches. And that's all for today. So that's the end of the class for today. I'll see you all next week.